Good morning, learners. Mr. Pizzo from Monteo District, subject advisor of mathematics, grade 8 and 9. Let's check. Today we are going to do straight line geometry. Okay. We are going to do angle relationships. And we need to revise and be able to clearly describe the relationships formed. As you remember that mathematics is a relationship subject, which explains something in relation to something. Right? In those relationships, we'll be finding out what are perpendicular lines. What happens when lines intersect. We'll also talk about parallel lines that will be cut by transversals. After that, then we'll be solving problems of geometry by using that relationship between pairs of angles, as we've already spoken about above. So you must watch attentively so that after that we'll be able to make an application and solve some problems. Let's see geometry of a straight line. What is this line? How does it come about? Very easy to explain. I've just plotted a point there, or a dot, and when you look at that dot, you will not be able to measure. It does not have dimensions to the right, to the left, vertically, horizontally. It's just but that simple dot which is called a point. That's what it is. Now let's see the magic of this point. What does this point do? And exactly you tell me what I'm doing, then we'll be together on this trip. All right, let me just take the ruler. I'm using my points. Let me just do this so that you can see. I'm using my points. I'm using those points. Using those points. And of course, what did I do? I just joined the points. Just joined the points. So, explaining this, joint points, which is the beginning of the line. The line is just points that are joined. S is as that. Points up to wherever you want them, up to infinity. But the most important point is the points. And again, now those points, you can explain it in many different ways. You can say, okay, these joint points are starting from here to here. There's a starting point and an ending point. Starting. Where we started. Starting and ending point. Still a line, remember our line, just joint points, or combination of points, or lines up to infinity. Points, but joint up to wherever you want. So this one, where it has got the starting and ending point, it's called a line segment. In other words, just a reminder, just to make things easy. You know what's a line, it's what we're doing. We'll draw it quickly. Sometimes you might not even remember what we did, but we just joined points. So a line is just joint points, combined points. So there is an ending, a starting point and an ending point. That's when we talk about line segment. Same way, we start here, and this one goes, the arrow normally means it goes infinitely. There is a starting point, no ending point. There is a starting point, no ending point. Therefore, it goes on and on. Of course, as we all know that mathematics is a language, it's called array. But remember, everything is from the point. The point made that line. The point made that arrow. The point gave us a line. The point is giving us line segments. And then you also can say that array. And ultimately, of course, like we said, points non-ending. Non-ending, that is your line. They go wherever, straight line. But remember what is important, they are made out, a line is made out of points. How do you make a line? You just join points. What is a line? Join points. Combination of points, combine points. As he says, that is something that we do. Right. So far, so good. Now let's see how do we get around once more. Observe what I'm doing, internalize what I'm doing, try and explain what I'm doing. Tell me what I'm doing. Again, based on that point. There is a point. There is our point. There is that point. And you tell me what I did, what I'm doing now. A line that goes to that point. I drew a line, join points. Still remember? Again, what am I doing? A line once more to that point. So it doesn't matter. It's either lines to the points or from the points. The lines to the point, that line to that point, or this line to that point. You can just say, you can just call it an arm. Let's say arm AB, and then arm AC. But what is important is to observe what I've done. It's what I've done. And then we just have to explain it mathematically. Line through lines meeting at point. A line AB or arm AB and arm AC. Line AB and line MC. They are meeting at a point, and that point is called a vertex. Where lines meet? A vertex. Where lines meet? That's a vertex. Like I said, just observe what I'm doing and just understand and explain. So life is mathematics is an everyday kind of, mathematics is life, it's what we do. We just have to put it mathematically, the language. But anybody can explain what has happened. Anybody who are able to communicate with each other, or we can explain what happens and understand what happens. It's just that how do we take it to mathematics so that mathematically we can understand each other. Right. Again, let's look at this now. And there is a space between these two lines. There's a space between it. Once more, you analyze what happens. For the line to the point, and the line, another line meeting at that point, which is called a vertex. So we've got lines meeting at the vertex and a space in between. Right. So this space is called an angle. An angle, that space. If, for an example, I take these two pens that meet at that point, which is called a vertex, of course. Now, The angle is that measure how wide can the arms be apart. But remember the vertex. There's no movement there. How wide, how big is the space between the arms? Controlled by the vertex. That's what you call an angle. That's what you call an angle. The measure of how wide the arms are, how wide apart the arms are. That's an angle. So the issue is how to take it to mathematical language. That's how we take it to mathematical language. Right, now let's go further and see after that information. After that information, let's see, like we said earlier, you have to understand the angles formed, the relationships, using the lines that forms angles. When you intersect, what happens? We have seen it, it's just given us there is that instrument that we use to measure the angles. And when you see that instrument, which is called a protractor, an angle between the two lines, how wide are those two arms? How wide is that space? The measure between those lines is 90 degrees wide. It's 90 degrees wide, which is called a perpendicular mathematically. So at the vertex, they make an angle of 90 degrees, which is called perpendicular. Mathematically, we mean perpendicular. A vertical line and horizontal line meeting at 90 degrees. That's what we mean. Those are our lines, lines DC and lines AB. What is the relationship between the two lines? They meet at 90 degrees. In other words, the angle between those lines is 90 degrees, which is called perpendicular mathematical. Remember, mathematical we call it perpendicular. When you go into our homes, when we make tables, when you go to our books, the corner of the books, where do they meet? 90 degrees. The corner of the houses, the walls in the house, 90 degrees. When you look at that figure there in front of you, angle A and B, line segment AB is perpendicular to EA. In other words, the distance between them, the angle measure between them is 90 degrees, which is called perpendicular. Same thing with AB and BC. That's what we mean by perpendicular. And there are different kinds of angles. The right angles, you see the measure is about 90 degrees. Now, if you move the arms bigger than 90, and carefully, bigger than 90, it's called an obtuse. But it's between 90 and 180 degrees. 90 and 180 degrees. All right? Let's go here so that I can illustrate. What do I mean by that? What do I mean by that? What do I mean by that? Okay, let me try to put the white page here. Right. Our protractor there. Let's go at our protractor there and have a look at our protractor there. The straight line angle is 180 degrees. A straight line angle is 180 degrees. In other words, the size of that angle, straight line, is 180 degrees. Those two arms, remember, they meet somewhere. That's what we mean. So, again, we spoke about perpendicular. We said the other arm, with vertical arm with the horizontal arm, will give you 90 degrees. Right. And we're saying, if that's our 0 degrees, that is our 90 degrees. Any angle less than 90, between 0 and 90, is called acute angle. The measure is between 0 and 90. Anything that goes beyond 90 but less than 180, because here is our 180 degrees, will be called an obtuse. And again, it's what we are doing. 0 and 90 degrees, that is your perpendicular angle. Anything between 0 and 90 is called acute. It's just a language to explain an angle less than 90, between 0 and 90. Or further to explain the angle that is bigger than 90 but less than 180, an obtuse, so that we can understand each other when we talk about obtuse angle, what kind of angle we are talking about. And if it goes further than 180, here you'd be having a 270 degrees, 360. Anything further than, bigger than 180 is called a reflex. A reflex angle. Again, it's us between the language, right? Mathematics language. Anything between 0 and 90 is an acute angle. 90 degrees is our perpendicular or right angle. 90 degrees is our right angle. Anything bigger than 90, you find the 100, 110, and less than 180 obtuse. Anything bigger than 180 is called a reflex angle. So there's a lot of language there. There's a lot of language there. Let's look at and find out more. Like we said, a right angle triangle, which is a 90 degree triangle, and then an obtuse one is the one bigger than 90 degrees and less than 180. Acute is the one which is less than, it's between 0 and 90, below 90. Anything above 180 is called a reflex. Parallel lines, you can look at your table, at your desk, the front part of the desk, and there's one immediately next to you. The opposite side of the desk are parallel. The opposite side of the page of the book are also parallel. What is common about it? They never meet anywhere. Those two lines will never meet, like a railway line, or we make a route. Those are parallel lines. Remember, we said we want to get the relationships of angles, angles that are formed by a line. How do they relate? The two lines meeting at 90 degrees, what is the relationship? They meet at 90 degrees, and then we say they are perpendicular to each other. And of course, the line that goes, you can say on the horizon or on the flat, sort of, we call it horizontal, and the one that is 90 degrees towards that, either up or down, will be called vertical. Let's just have more, let's just have pictures of what we mean by parallel lines. And of course, anywhere in the house, in the classroom, you can see lots of parallel things. But what is important about them, those lines will never meet. Again here, on the second column, we've got the perpendicular lines, they meet at 90 degrees. Second column, you've got an example of parallel lines. They just go forever, they will never meet. the space between those lines is equal. You can even check your book, you can check your desk, whatever. You can check the walls of the house. They are, the space between is the same across. If not, then they are not parallel lines and there's something that is not right. And of course, the line will intersect. You know, at the cross where the roads are crossing or they meet each other, they go across each other, you call it an intersection when they meet, when they cross each other. Once more, it's a relationship. How do two lines relate? The first two lines, the vertical one is perpendicular to the horizontal one. The second one, the parallel lines, they will never meet. And the space in between is even, it's equal space. And then the last one, of course, where the line intersect. And when they intersect at that vertex, they'll give you an angle. That space between the two arms. Just a definition there, two lines are perpendicular if and only if they form a right angle. In other words, a right angle, what's a right angle? 90 degrees. Mathematically, we say 90 degrees. We have spoken about that. It doesn't matter where it's facing. It's not necessarily up and down. It's just a relationship between the two lines. What is the measure of the angle? If it's 90, they are perpendicular. That's what is important. Just as a way of illustrating what do you mean by perpendicular, so that we can internalize it. When the lines meet, when the arms meet, what kind of angle they form. If it's a 90 degrees, we call it perpendicular, which is called a right angle. And of course, we indicate it by that half box of a square or rectangle. Then you know that science means 90 degrees. Once more, just a point of emphasis. If they are meeting at right angle, they are perpendicular. I've spoken about the horizon earlier on, and a line that goes up vertically or down, right angle. Like I said, it does not matter where they are facing, whether they are slanting, whether they are sloping to the left or to the right, or they are upright. What is important? The relationship, the size, the angle between them. If it's 90 degrees, then we say perpendicular. Now, remind yourself. We said a straight line angle gives 180. Now, with the information that we had. In other words, angle A, which is A to a certain degrees. Remember, A means unknown. We have to solve it. We have to solve it, which will also take us to our equations. Angle B degrees and 35 degrees, and C degrees and 74. Let's see whether do you see a straight line angle there? And then we said, what is the size of a straight line? You can look at the extreme right. Angle of a straight line have a sum of 180. Angle of a straight line have a size of 180 degrees. Right. I'm writing these three questions here, and then you are going to help me solve them. You are going to help me solve them. Let's look at the right here. Angle of a straight line, 90 and 90 gives you 180. Therefore, the straight line angle is 180 degrees. All right? The next figure says, same thing. The angles that form a straight line When you add them, they should give you 180. When you add them, they should give you 180. So 120 plus 160, 180 degrees. 60 plus 120, 180 degrees. Let's see now, from that understanding, can we solve this? Let's see. Because here we are talking about a straight line. Straight line angle equals to 180 degrees. Remember that. Remember that. Therefore, 50 degrees and 8 degrees, they form a straight line, which means 180 degrees. Which means 180 degrees. All right. Now, what is the size of A? To get 180, what is the size of A? The other one is 50. What should be the size of the other one? Of course, 130. 130, meaning that the size of this is 130 degrees. But remember, it's your understanding of a straight line angles. When you add them, they should give you 180. And of course, what is the reason? The reason is straight line angle. Same way here. 35 degrees plus a B degree. When you add them, they should give you 180 degrees. Why straight line? Straight line angle, because straight line angle is 180 degrees. So for you to get 180 degrees, what do you put here? What do you put inside? For you to get 180 degrees, what do you put inside? What do you put inside? In other words, this one should be 106. Therefore, C degrees 106. Because 106 degrees plus 74 degrees gives you 180 degrees. Same thing here, what we are going to add here? 145. Therefore, B is equals to 145 degrees. Because 145 degrees plus 35 gives you 180 degrees. So that relationship is important. A straight line angle, 180. Whatever angles you have, whatever angles you are given, when you add them, they'll give you 180 degrees. What is the reason? Angles on a straight line. You can also check the second one. The second one, what will be your D degrees there? If this is 40, what do you add 42 to get 180? What do you add 42 to give you 180? Of course, 140. So 140 plus 40 will give you 180 degrees. What is the reason? Straight line angle is 180. Because in mathematics, you give a statement and a reason. Same thing with this one. Degrees or even F here. For you to get F is 140. But look at that relationship. There's another relationship here. That angle D is 140, angle F is 140. So these two angles, let me just explain them. Let me just get this one. $40 degrees, D degrees, F degrees, and E degrees. Okay? Let me just go to that one. That's a situation here. Let's also observe and learn something. We said angle on a straight line, they should give you 180. Therefore, 40, what do you add 42? You get 180, 140 degrees. What do you get 40 on the other side, the straight line there? What do you add 42 to get 180 degrees? 140 degrees. Once more, on this straight line, what do you add 142 to to get 180? 40 degrees. But observe something here. Please observe something. This angle is now equals to that one. Right? 140 degrees equals to 140. Now the question is, what is the relationship? Do you still remember our vertex? Do you still remember our vertex there? They've got a common vertex. And then the reason thereof is called vertically opposite. So we should not confuse it with 90 degrees. Vertically opposite, in other words, opposite in terms of the vertex, the vertices. Or in this case, it's a common vertex, it's 1. So that is why this angle is equals to this angle. Vertically opposite. Remember we said relationships of angles. What is the relationship of angles? We just explain how do they relate. Vertically opposite angles, they are equal. Vertically opposite angles, they are equal. Angles on the straight angle, they give you 180 degrees. So we are defining the relationship, but of course we take it to a maths language. In other words, it's a day-to-day life. Just want to put it mathematically, so the mathematicians, when they speak, they understand what they're talking about. They must say the same thing. So in other words, mathematics is life. It's what we live. Just effort is how do you put it in another language. That's all what is important in mathematics. Okay, let's carry on there. Now we've seen here as well, when you go to your extreme right there, your green angles vertically opposite. And my advice, when you look at these pictures and the colors, my advice to you, whether you are in grade R or in grade 12, make use of crayons. Make use of the coloring matters. I brought along my crayons here. They'll assist you with coloring. You color same angles, just to make the picture clear. In English, when they speak, they say, do you get the picture? And when they say, do you understand? Just to clarify your picture of yourself. The crayons make life easy, especially for starters. After some time, then you'll be a master, of course. You see the vertically opposite angles there, colored in green, 60 degrees, 60 degrees. Other vertically opposite angles, 120 degrees and 120 degrees. So it helps a lot. It helps a lot just to make a picture clearer for you. Now let's continue talking the relationships of our lines. Let's continue talking relationships of our lines. Let's continue talking relationship of our lines. This line, how do these lines relate? How do they relate? How do they relate? How do they relate? You see the corner of the page. Am I right if I do this? Am I also right if I do this? Yes, because those two lines, where they meet, it's 90 degrees. That means it's 90 degrees. That's what it means. Now, let's see now. We want to draw, okay, let me do this. We want to draw this line, same distance as that line. Okay, let me just do this guy a little bit so that you can see. Right, I've drawn those lines. And we say they are parallel because the space in between is the same. It's the same distance. From here to here, from here to here, from here to here. Those lines are parallel and they will never meet. And with this instrument of mine, this line and that line, yep, they'll never meet. This line and that line, they'll never meet. Sides of a page, opposite sides of a page, they'll never meet. Now, when we draw a line like this, again you must observe what I'm doing. Draw a line across the first line, then across the second line. So that line is intersecting both lines at different points. And this line is called transversal. Again, it's just mathematical language. But it's that line that you drew from one line to the other line. It's called a transversal line. You still remember the size here? 180 degrees. Do you also still remember the size here? 180 degrees. Do you still also remember the size of the angle here? 180 degrees. 180 degrees. That's very, very important to remember. So that line is called a transversal line. Two lines, line intersecting both lines. Therefore, it's a transversal line. That's line. It's just the language of mathematics, what it is called. It's called a transversal line. It's called a transversal line. Right. Just an example or definition, or also getting a picture. We'll deal with this a little bit later. But a transversal line is a line that intersects two or more lines. And look, we'll deal with them a bit later. Look at corresponding angles. Corresponding angles, the first one. Let's look at okay. Or let me just use same colors. Let me go back here and use the same colors. Let me use the same colors. Corresponding angles. These angles are called corresponding angles. Corresponding angles. Look at how they are positioned. They are both underneath the parallel lines. You can say more or less position is corresponding. It's not the same position, but relatively speaking, it's under this line and on the other side of transversal. Under this line, which is parallel to this one, and on the same side of a transversal. It's called corresponding angles. Same one, this one is above this line on the other side of a transversal. This one is above that line on the other side of a transversal, which is called corresponding angles. Corresponding angles. Corresponding angles. Same. This one, look at the position. just above that line, just above and on that side of a transversal. So I'll be explaining on the PowerPoint, and after here, maybe we need to do some exercises now. Let's do some exercises. But let's have a look at this. When we go on, we'll be dealing with each one of them. So my request is for you just to check the position of each between the parallel lines and your transversal line. The first one, like I said, is your corresponding angles. Just above a parallel line on the right side of a transversal. Just above this parallel line on the right side of a transversal. They are called corresponding. And then the next one is alternating on the other side of the transversal. Alternating, changing on either side of a transversal. On the other side of the transversal, this other side of the transversal, those are called alternating angles. And of course, that one is alternating exterior, they are outside. And our popular straight line angle, which is also referred to as supplementary. If you add the angles, they give you a straight line, they are called supplementary. And then the one of 90 degrees, they are called complementary. I spoke about vertically opposite angles, vertically because of the vertices. And of course, co-interior. In other words, they are inside, look, they are inside the parallel lines, but on the same side of a transverse. Inside the parallel lines, on the same side of a transverse. They are called co-interior or right. From what we've done, let's see our understanding. And what is important when you deal with this kind of question? You must read each and every information. You know, in Sesotho we say, yeah, you can, but it must. Every information is important here, whether it's decorating whatever, because if you miss something, for example, if somebody gives you a direction to go to Botshabelo or Kimberley, just say, drive to Nelson Mandela and then join N8. There's information, insufficient information, some information lacking. Are you going to the right, to the left? Are you going up or down, north or south? So you won't be able to. So it's important to read each and every in your question, especially when it looks like you are a bit confused. When it looks like you are confused, then reread the question. Right. In the diagram below, OABC is a straight line. A straight line. You see, they call them keywords when you do essays or in English. So straight line. You still remember what straight line is saying to us. Straight line in mathematics says it will give you 180 degrees. Straight line in maths means 180 degrees. Right? And we'll go for end. Angle EBD. Angle EBD. Angle EBD. Before I go there, let's deal with angles as well. Naming of angles, we did not deal with that one. Let's deal with naming of angles so that you will not struggle. Remember when we started, we spoke about our arms. Let's see. Our arms, right? Let's say you've got A, B, C, D, E. Depending what angles you are referring to. You are referring to this angle, the common vertex here, it's a C. Now we are referring to this angle. But that angle This angle is formed by arm BC. And that angle is also formed by arm AC. BC, AC. So it's either you say angle BCA, BCA, or angle ACB. So my advice is B, where do they meet? They meet at C. What forms them? B and A. They meet at C. So it's BCA, B and A, or ACB. Same thing when we refer to this angle. What forms that angle? BC and DC. BCD. What forms this angle? BC and CD. So BCD, BCD, or DCB. We're referring to this angle here. What forms it? DC and EC. DC, EC, DC. C is common, so it's in the middle. C is common. DCE, 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 ECD. AC and EC. What is common? C. Therefore, what arms? AC and EC. Side DC and side EC. What is common is your C, therefore is your DCE, angle DCE. Or you go the other way around, what is common? C, ECD, angle ECD. Naming of angles is quite crucial and it's important to know. Most of the time it's just 3-letter. If it's a standalone angle, that's when you can say, for example, A, B, C, D. Clearly you can say angle A there. Angle B is a standalone. Angle C or angle D. But if there are lots of angles around a common point, therefore you have to specify BCA, ACB. I just wanted to go back there and say naming of angles before we continue. All right. Let's look at it, work at it. Like I said, the statements. Which one is your straight line? Which one is your straight line? Let me go here. We say OABC is a straight line. OABC is a straight line. Okay. Now, OABC is a straight line. EBD, they tell you, EBD is equals to y plus 10. EBA, E, the first letter, A, the last letter. E, the first letter, A, the last letter. What is common? B. EB, AB is 3y minus 20. Now the question is determine the size of angle Y. The size of angle Y. Right. Straight line. You remember when they refer to straight line. Straight line. What does that mean? So it tells you the whole angle is 180 degrees. It tells you. But if that is 180 degrees and this is 90 degrees, straight line, 180 degrees. Straight line, 180 degrees. That line, that angle. OABC. OABC, that is a straight line they're referring to. This one as well will give you 180 degrees. So this angle will give, if the whole straight line angle gives you 90, what is this one? This one is supposed to be 90 as well. So the question says determine the size of y and give reasons for your answer and show all your working. Show all your working. Right? Let's start working now. We determine the size of y and the reasons thereof. Therefore, your statement is advised in your straight line geometry. You will give a statement and your reason. Statement and your reason. State what you see, what you know, what you understand, and why that is true. Why? Why do you say so? Right? Let's go back to our question. Angle DBA, angle DBA, angle DBA, this angle, plus that angle, gives you 180. Angle DBA, this angle, DBA, DBA, D, I'm DB and I'm AB, DB and IB, this one, plus this angle DBC, DB and BC, they give you 180. Now the question is why? So you are stating angle DBA plus angle DBA, this one, plus DBC. Do they form a straight line angle? Yes. So when you add those angles, because they are on a straight line, they'll give you 180. Why? Straight line. Just give it a straight line. That is your reason. But now when we go back to DBC, DBC we are giving is equals to 90. Remember that sign means 90. Therefore we say, okay, DBA plus 90 degrees equals to 180 degrees. DBA plus 90 degrees is equals to 180. Okay, let's do this. Let me give you a chance to analyze that. Let's give a break of a few minutes. I'll come back. In the meantime, just analyze that question and try and solve it. We'll come back and do it after. Let's take a break. When I take a break, just have a look at it and work at it. Thank you very much.